Hey guys, today we're going to do section 2 of chapter 7 called slope fields. We are going to be creating our own slope fields. We're going to be analyzing slope fields. So first and foremost is to see what one looks like. And basically all you have to do to create a slope field is use a differential equation, plug in a point, find the slope, and draw these little lines which represent the slopes at those points. Now the easiest ones only have one variable. Also, the easiest ones only have a few points, like this one. So what we're going to do is we're going to look at dy dx equals 3x minus 2. We're going to look at our graph for x equals -2, -1, 0, 1, and 2. And we're going to find the value of the slope by plugging x into our differential equation. So -2 is x. So times 3 minus 2 is -8. So -3 minus 2 is -5. 0 minus 2 is -2. 1, 3 minus 2 is 1. 2, 3 times 2 is 6. And 6 minus 2 is 4. So the easiest ones to draw are the slope equal to 1. So when x equals 1, the slope equals 1. So you're just going to draw a slope that is approximately 1. So once you draw 1, probably the next easiest would be -2 because it's going to be just a little bit steeper than that, but it's going in the opposite direction. So a little bit steeper, and that is our at x equals 0. And then from there, you can just kind of do whichever ones you want. So this is m equals 4, a little steeper. Notice they're all the same. And then at -1, you go -5. And then at -2, you go -8. So again, that's the simplest kind where you only have one variable, and so your slopes are pretty much uniform. Now, if we were to take this differential equation and find our general solution, just a little bit of practice here. Y equals 3 halves x squared minus 2x plus c. So if we were to graph that, it should follow this curve. It's pretty cool. All right, we're going to jump right into two variables here. So we're going to have to choose an x value and a y value that corresponds to the points here on our graph. And then we're going to find the slope at those points. And we're going to start that process by solving our equation for dy dx. So we're going to subtract 2x and divide by -y. So subtract 2x and divide by -y. Our differential equation is 2x over y. So we have the points -2, 2, -2, 1, -2, 0, and then -2, -1, and -2, -2. We can do 0 very easily without filling in our chart. So -2, 2, -2, 1, -2, 0, -2, -1, and -2, -2. And then we will put on there 1, 1, 1, 0, and 1, -1. And then if we need to add more points, we can do that. We know that when x equals 0, your slope is 0, except at 0, 0, which does not exist. Y cannot be 0 here. So when y is not equal to 0 or not able to equal 0, There's nothing on the x-axis. Now, when you have multiple points and you know it's not going to follow a pattern, you can do them one at a time. So -2, -4 over 2 is -2. So at -2, 2, you have a slope of -2. At -2, 1, 2 times -2, -4 over 1 is -4. A little steeper. At -2, 0, we know this point does not exist because y cannot be 0. We also know that this one is going to not exist. We can go ahead and fill that in. -2, -1 is +4. And -2, -2 is going to be +2. All right, so 1, 1 is going to be +2. And 1, -1 is going to be -2. And then out to the side, you can just fill in the rest of your points. So at -1, 1, -2, and we'll go ahead and fill in at 2, -2, also going to be -2. So those are in a line that are the same right there. All right, we said those were -2. At -1, 2 is -1. At -1, -1 is 2. And at -1, -2 is 1. Just picking the points here on the graph. So the ones I have left are 1, 2, 1, -2, 2, 1, 2, 2, and 2, -1. So 2 over 2 is 1. 2 over -2 is -1. 4 over 1 is 4. 4 over 2 is 2. And -4. And there's your slope field. Now, if we were going to create our differential equation here, I'm going to kind of give you a preview of what we're going to do next. You have to do what's called separation of variables. So what would happen here is we would say y dy equals 2x dx. So this is y squared over 2 equals x squared plus c. Subtract the x squared. Now I'm going to do two things. Change the sign and multiply by 2. And that would be your general solution. Consider the following differential equation, dy over dx equals -x over y. Compute dy dx at each set of points, and then answer the following questions. Okay, so if we plug in 1 for x and 1 for y, we get -1. If we plug in -1, that'd be 1. 1 over 1 is 1. So this would be -1, and this would be 1. So dy dx is positive Where are these located? All right, this is quadrant 1. Negative 1, 1 is quadrant 2. Both negative is quadrant 3. Positive, negative is quadrant 4. So dy dx is positive in quadrants 2 and 4 and negative in quadrants 1 and 3. All right, what if we had 1, 0? Undefined, 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 undefined. We know y can't equal 0. It gives us a vertical slope. So we know that the slope is undefined at any value, x equals a, any vertical line. And we know the slope is 0 at any y equals b, which is any horizontal line. Those describe all vertical and all horizontal lines. X equals a number of horizontal, x equals number of vertical, y equals a number is horizontal. All right, plug these in. 1, 1, 2, 2, negative 1, negative 1, and negative 2, negative 2. So what equation would express dy dx equals negative 1? Y equals negative x, negative slope. Y equals 1, y equals positive x. All right, so we're going to use the grid at the right to sketch the slope field for the values calculated for A, B, and C. We're going to draw the particular solution that passes through the point 0, 2, 0, 2, and then what is the equation for the solution curve? All right, if you will take just a second and pause your video, I want you to plot your points. At 1, 1, you have a slope of negative 1. At 1, 1, you have a slope of negative 1. At negative 1, 1, you have a slope of 1, etc. So the work is done for you. You just now need to plot your curve. So take just a minute, pause your video, do that, and we'll come right back and show what your answer looks like. So the green that you see here represents the points that you just created in those 3 charts at the top of the page. Notice it goes through 0, 2. The pattern of the slopes follow a circle with the equation of x squared plus y squared is equal to 4. Continuing with this question, explain what happens to the slope values as you move from left to right with a fixed y value. If y is greater than 0, then dy dx decreases. If y is less than 0, then dy dx increases as you move from left to right. And what happens to the slope values as you move up from the x-axis with a fixed x value? It is undefined at the x-axis and decreases as you move up. Now, our next example is asking you to match a differential equation to a slope field. So what I've done here is given you some hints. I'm going to go through 1 or 2 of them with you. And then I want you guys to pause your video, fill in the rest of them, and then we'll conclude our lesson on the next page. All right, let's look at 4. Your differential equation is cosine x. So if we were to take the antiderivative of cosine, we would get sine. So we're looking for the sine curve. We know we're going to go through 0, 0. So if you take a look at your differential equation slope fields here, remember your sine curve goes through 0, 0. Sine curve goes up, down, down, up to complete a period of the sine cycle. So as we look at these, starting with number 1, that one is going to look more like that. Well, we don't have a sine curve that big unless we have a transformation, so we know it's not A. This one doesn't go through 0, 0. This one, C, looks like a cubic function. You see that? See how it follows that? A cubic function for C. D is blank over here, definitely not. E is blank here, definitely not. F appears to follow a sine curve, but these parallel slopes are not going to be indicative of that. G doesn't follow the sine curve at all, but H does. It's going to go through 0, 0, and go up. See how that goes up and down and up. So 4 is H. I think with these hints, you'll be able to figure most of these out. So again, I want you to pause your video, take just a minute to fill in the rest of your multiple choice, and then we'll move on to example number 5. All right, number 1 must be greater than or equal to -2 with BD. Choose 0 and a number. That means your slope is 0 because e to the 0 power is 1. So whatever your number is will work there. So that one will be A. Sine y plus x, when y is 0, the slope is equal to whatever value you have of x. That would be G. We've already done number 4. E for 5 because it must be greater than 0. 6, do you remember me talking about C being a cubic curve? The antiderivative of a square is a cube. So C. X is 0 or y is 0 means the slope is 0. So that one would be B. And then similar to the sine curve here would be F. Remember we talked about that? This one's similar to the sine curve, but it had those parallel slopes. That would be because of the angle of cosine here. All right, example number 5, a differential equation, a point, and a slope field are given. Use the slope field to sketch a particular solution through the point. Then use integration to find the particular solution of the differential equation. So we know we're going to go through 0, 1 and plot that. The other thing you should notice is that we're going to have a vertical asymptote at -2. Notice how at -2 your slopes split. There's nothing at -2. So I'm gonna go ahead and graph that vertical asymptote at -2. So we're going to take the antiderivative of both sides. So y equals ln, absolute value of x plus 2 plus c, plugging in 0 for x and 1 for y. We're solving for c. So c is 1 minus ln 2. So f of x equals ln, absolute value of x plus 2 plus 1 minus ln 2. That would be your particular solution. So I'm going to use my graph. Excuse me there. ln, absolute value of x plus 2. And I see a mistake here, so I'm going to close parentheses there, plus 1 minus ln 2. And I'm going to graph that in my calculator. Notice I have here my vertical asymptote. We're just going to follow our curve. And even out. And how to distinguish between slope fields? What strategies and trends do you look for when matching slope fields? If dy dx has an x in the problem, the slopes change left to right only. If it has y, the slopes change up and down only. If it has both x and y, the slopes will change in both directions. Find out what conditions will make dy dx greater than 0 or less than 0, and then find where dy dx is 0 or undefined. This concludes section 2, which is slope fields. Let me know if you guys have any questions, and I hope you have a great day.